Hi there, I'm Anton. I run a blog and a YouTube channel called Anton's Mindstorms Hacks because I like to stretch the limits of LEGO hardware and bricks. And the star of this show today is this robot here with Mecanum wheels. If you like hacks like these, like Mecanum wheels, remember to hit the subscribe button down there because your subscription is part of what keeps me going on here. I really appreciate it. Now, once you have subscribed, let's go on here. The cool thing about these Mecanum wheels is that they allow the robot to run in every direction. So you can run sideways like this, forward, backwards, of course, and you can make the robot turn around its axis. These wheels go perfectly with the new Robot Inventor kit here because there are 4 motors in that kit. 1, 2, 3, 4, and to drive a Mecanum wheel robot in all directions, 4 motors is what you need. Then you can get most out of these wheels and you're able to make the robot move in every direction. Because of these motors, I thought this is a robot waiting to be built, so today I did it and I'm showing it. It works great with my remote control app, but you can actually use any device to remote control it. So you can use a simple remote control thingy like this, or you can use a more complex steering wheel like this. It's got flappy paddles and you can steer the robot by tilting it sideways. Let's have a closer look at how these wheels are connected to the Mindstorms motors here, because I had to print a 3D print a little adapter hub to make sure that they stick to a Lego axis. This is the 3D printed part. It has a hole on one side that fits an M4 screw, and it's got an axle hole on the other side that fits this tree long axle. You can simply insert the connector hub module here into the wheel and then use, this is a 10mm M4 screw. These are very common screws. I had a bunch of them laying around. They can come with a Phillips head or with a flat head. I happen to have a flat head laying around, so you can then just screw this in very easily. Okay, until the end, and then there is this tree long axle that you can just put in there, and it's got a nice stick factor, so it's solid. You actually need pliers to pull it out again, but it's not damaged or anything. It just fits in quite tightly, which is nice because the wheels generate some sideways force, and the tight fit makes sure that the wheels stay onto the vehicle without needing a brace here over the outside on top, and the vehicle just looks a lot cooler without the outside brace. Make sure if you buy wheels that you buy left hand and right hand wheels. So there are 2 types of wheels. So here and there is left hand wheels, there and there is right hand wheels. Once everything is set up, make sure that also the rolls are oriented like this. They are pointing inside on top, but they are rolling to the center at the bottom of the robot. That ensures that the robot can have full maneuverability. Now there are 2 kind of wheels with wheels on the side. You have these holonomic wheels or omni-wheels or rotocasters, and you have these Mecanum wheels. Both are awesome wheels, but they have completely different properties. The maybe more popular rotocasters or Omniwheels, they have no friction sideways and they have no friction forwards, at least if you put them on a rotating axle. Here is a typical robot that uses the holonomic rotocaster Omniwheels, and it can move everywhere by varying rotational speed here on these wheels that are mounted perpendicular to the center of the robot. The rotocaster is a wholly different beast. It needs at least 4 wheels. That's why it goes great with Robot Inventor. It doesn't work on 3 wheels like the Omniwheels here. So, but I think it's an advantage because robots with 4 wheels are easier to build than robots with 3 wheels. And what really makes these kind of wheels stand out is that if you move them sideways, they start to turn. Or conversely, if you turn them, they will move sideways. That is, if you hold them. So that's why these 2 wheels here are mirrors of each other, mirror parts. And if you move them in, if you counter rotate them, you get this sideways force that it creates. And the counter rotation makes sure that the robot stays in place and doesn't start moving forward and backward. So the counter rotation cancels any forward movement and makes sure that all of the movement is sideways. If you then counter rotate these like that and those like this, the robot starts to rotate around its axis. If you move them in the same way, the robot goes forward. If you move them if you counter rotate them all, the robot can strafe. I received these wheels courtesy of DF Robot. I think they look awesome on this particular model. If you're a LEGO purist, you can also use LEGO only Mecanum wheels. And this, for instance, here is a model by Yoshihito Isogawa. They work, but the performance is a bit less than dedicated Mecanum wheels. If instead of the non-LEGO wheels you want LEGO wheels, you can build these wheels by Yoshihito Isogawa, and just make sure to mount them in the same fashion. So these wheels, they roll outside. This is the wrong wheel. This is this is the right wheel. So okay, this is right for that position. This is a mirror wheel, so we can put it here. And these wheels should also be opposite. So that wheel goes there, and this one goes here. Now we have the same setup. I think it looks a little less cool than with the big wheels, but it's a full LEGO model, and it performs almost as well. There is a bit more friction here, and these wheels tend to stick sometime, but it works. Just not as well as these dedicated Mecanum wheels. Now to remote control this Mecanum-wheel robot, you can create a Python program. So by default you get a word blocks program, but we want to do Python. And then this here isn't very helpful for remote control. We need to go to my GitHub, where I have all kinds of boilerplate code to get your remote control project started. So let's go to RC receiver boilerplate, copy the whole thing like that, not the bits at the bottom, and let's paste it here in a new script. Let's enlarge it a bit so you can actually see it on YouTube. There we go, paste it, and there we have it. It's the basis of a remote control script. It imports the robot tools that we actually still have to install. So hang on, we will be installing it soon. And then it creates some objects here, like a motor and a receiver, and then it has this infinite loop here that checks if the receiver is connected, and then depending, and then puts the values that it's received into motor powers, and if it's not connected, it stops the motors. So this is a simple control loop for remote control. But then here you probably haven't installed the robot tools. To do that, we'll create another project. So let's create another project here, an empty project. We're going to clear all that, and let's go back to this GitHub. I'll put the link in the description, and then here you have the installer, and then click the install MPy robot tools script. And this is also a script that you can completely select, Command C on my Mac, and then moving over here to Mindstorms, paste it, and just I'm going to run it in a different slot. Run it in slot 2, just run it once. I like to open the console to see if any error messages show. It's compiling, it's taking a while. I don't know why. It's a good moment to hit the subscribe button while we're waiting. Okay, there it is, it's running. It's probably quite large and it had to download it. It disconnects the hub, also disconnect the USB there for the hub, so it can reboot and then reconnect the USB. And we're all set, we're back up, and the library here is installed. You can discard this project, you don't need to ever run it again. Right now the tools are installed and we can start using them. Oh, by the way, if you are doing remote control projects, make sure that auto connect is disabled. Oh yeah, I'm using USB here to connect to the hub, but if you're using Bluetooth, make sure that auto connect is disabled, because that will mess with the Bluetooth remote control code. Now we evidently have more motors than just motor A, so let's define that, and let's start with motor A, for instance. Let's have a look. Motor A is the front left motor. Let's call this one front left motor. And next, let's copy this a few times. The front right motor, it already starts to sound like a car, is B. The back left motor is, let me check that, is E. And the back right motor, brum, this also sounds like an engine, is F. Back right motor. And so now our motors are defined. Here, while the receiver is connected, we're getting the speed from the right stick in the vertical axis and the turn rate from the right stick in the horizontal axis. So the right stick is going to do speed and turn. Let's make this one left stick horizontal. So the right stick vertical is speed. It's the first parameter. Turn, we want that from the left stick horizontal. That's cool. There are buttons on the remote control, so this one will beep if you press button 1. Let's leave that in. And then we have to start our motors. Let's start our motors. So the front left motor, we're going to start that at speed. And I'm using this other imported function here, clamp int. This will make sure that whatever value you put into this function or method is clamped within -100 and 100, and it's an integer, because this method here, I believe it tends to balk if you put in numbers higher than 100 or lower than -100, or numbers that aren't integers. So to be sure that it gets the right kind of numbers, I created this method here. Now this is okay for our motors, front left motor. So let's copy this a few times, and front right motor, front back left motor, and boom, there we go. Now let's think this through. The front left motor runs in an opposite direction as the front right motor, so we'll make this minus speed, and same is for the back left motor and the back right motor. If we want the whole thing to run forward, depending on the speed, we have to reverse the speed. So let's put a minus there in front. I'm going to put a space there so everything is aligned, and this should actually be our first remote control program that just runs the robot forward and backward. Let's boot up the script and also boot up the app. Oh, we made a mistake. We left in MA somewhere. Of course, here we left in motor A. We should clean that up and make sure that we stop all our new motor objects. So that's front left motor, flum, flum. Let's stop it. Let's stop the others too. Frum, blum, and brrm. Let's stop all of these motors and let's try that again. Okay, wait says waiting for connection. That's good. Now let's open up the app. Let's scan here. It finds a robot. Let's connect. Okay, it's connected. The yellow light is lit. Now let's move forward. Wow, it works. So here on our right stick, it actually crashes into Yoshihito's wheels there. Boom, boom, boom. We can actually move slowly if we pull the stick a little bit and move slowly back there. Okay, so this works. We have forward movement, but we don't have turning movement, and we don't have strafing. So let's program that in. Disconnect here for now and stop the script. Now to make this robot turn, we have to add the turn factor. So let's just add turn to the front wheels, and here we don't have to invert the turn factor because we want to actually have the wheels turn in opposite direction. So if we don't reverse them, they will automatically start running in opposite direction, and then on the back side we will feed it the reverse turn. So we get this opposite movement of front and back wheels, and this will give us hopefully this rotational movement that we need. Let's run this script again. Okay, running, connect here the app and see if it, oh, we're strafing, we're not turning. We did it all wrong. But that's cool. So we accidentally discovered strafing, but strafing is in the opposite direction. So let's disconnect here and change the program. Now this apparently is strafe. Let's add in the right stick horizontal for strafing, and so strafe. So now we have strafe and speed on the right stick and turn still on the left stick horizontal. So this order here in which you add the parameters matters, but then we need to replace this by strafe because this parameter was actually our strafe parameter, and we need to reverse the signs because we were strafing in the wrong direction. And then finally we can add turn. So let's add turn here, and if we add turn in the same amount to all wheels, we will get this turn movement, because then front and back will run opposite. Let's run this program again. Connect the remote control here. Let's see what happens. Okay, there we go. So now we have turn, but the turn is opposite from the remote control. So because if I press the stick left, it actually turns right. We have to reverse the sign still. And let's see, and our strafe here, strafing works on the right stick, albeit a bit fast. So let's disconnect again and make one last correction here and just reverse the sign of our turning factor like this. Run it again. Boom, and connected, and now we have it. So let's turn slowly left here. Whoa, that was quite a lot. And let's drive forward slowly, drive backward slowly, strafe to the right. I'm destroying everything here on my table because the robot is moving quite fast. But there you have it. It's a robot with Mecanum wheels, remote controlled here with the app. Of course, you can also use this one for remote control. It works just the same, then you can steer. The app is just here for convenience, and you probably have one of these phones in your pocket anyway. This will set you back another 300 euros for an extra kit, but it's a lot of fun too. And if you don't want to build this complete wheel, the building instructions for this one are free, by the way. So click the link in the top right corner to get these building instructions. If you don't want to build this one, you can also build that one. It's a much simpler remote control. You can turn and do throttle here, and this will also connect to the same receiver script if you use a transmitter boilerplate, and then you can just hub-to-hub remote control all of your robots. Okay, this concludes my video about this Mecanum-wheel remote control car. I hope you enjoyed it, and remember to hit the subscribe button down there. I hope to see you in the next video. Thanks for watching. Bye bye.